Okay, for today. Yesterday, once you click and closed, yesterday we looked at definitions of functions. We found domain and range and determined if different representations of relations were functions. Today we're going to look at evaluating functions, using function notation and evaluating functions. So you guys know what function notation is. You've heard this for years. F of x is just a fancy name for y, right? So we know that if we want to write the equation y equals 2x plus 7 using function notation, we're just going to replace the y with an f of x, which doesn't doesn't change the look of the graph or the nature of the graph in any way, but it is useful to us because when we write something in function notation, it's telling us what is the input variable, and then this is the formula or the rule that I'm using to calculate the output variable, right? So if I write this in function notation, what is the input? X is the input. We know that because that's what's going into the function in function notation. What's the output? Okay, true, specifically, but just generally, if I want to think of it as kind of a variable, what's the output? F of x. Over here, it would be y, wouldn't it, if we write it with x's and y's, but now y becomes an f of x, so f of x is the output. And finding the value of, evaluating a function is stuff you guys have already done. It's really easy. If I know f of x equals 2x plus 7, then f of negative 3 is what? How would I find what f of negative 3 is? Plug it in. And make sure when you're evaluating a function, you always plug in the variable, the value of the variable in parentheses. Very important. So 2 times negative 3 plus 7, which is what? 1. Yeah, 1. And it's no big stretch to evaluate functions at bizarre numbers. I mean, it's like we can do this one manually, but we could also use Desmos, right? That's a lot of times when we evaluate functions, we want to use Desmos or our TI-84s. My TI-84 emulator is, they were working on it yesterday and they couldn't get it installed, but they'll figure it out here soon, I'm sure. And so I'll have that and I'll show you how to do all this stuff on your TI-84. We'll take a day and I'll just go through and we'll just talk technology on the TI-84. But for now, we'll just be using Desmos. So f of 3/10, what am I doing? Plugging in 3/10, right? Be easier to do on Desmos because I would just define f of x in one row on Desmos, and then the next row I'd go down and I would just enter f of 3/10, and it would give me the output negative 31 halves, right? Without having to go through and do all the simplification manually. Same thing with number 3. G of 0.4 means I'm just plugging in 0.4 into the function g. Now it is really important here that you put, if you're doing this manually, you put the 0.4 in parentheses, because if I don't, people are likely to miss that first term. They're likely to square the number negative 0.4 instead of squaring positive 0.4 and then multiplying by the negative coefficient. Right? Because only the x is being squared, and then I'm multiplying the result by negative 1 in the function. Everybody see that? Give me thumbs on that. So you see the importance of always putting the input in parentheses. It's a big deal. What would I be doing in number 6? What in the world is that? 2 times g of 12. There you go, right? There's really 2 parts to this. First, I have to figure out what is g of 12, but the way we want to think of that, when you see something like this, what you're thinking is, it's just a number. It's just an output number that I have to calculate, right? But I'm just multiplying 2 times some number, right? The output number when I input a 12. So first step would be, you got to figure out what is that output number. If I plug 12 into g, I just get what? I get negative quantity 12 squared, that's negative 144, plus 9 times 12 is 108, minus 1, When all the dust settles, I get negative 37 for that output number. And then I'm just going to multiply that output number times 2 and get negative 74. Okay, no big deal. Give me thumbs. How we doing? Good. And then even for weird ones like this, like look at q of x, the absolute value of 3x minus x cubed. You know, it's the same stuff. I'm just going to input 5 for x and see what I get. I'm going to evaluate everything inside the absolute values, and it turns out that I get negative 110 inside the absolute values when I plug in 5. Absolute value makes it positive. Okay? All the same stuff. Okay, what does this mean? Why don't you crank out, maybe bust your notebooks out if you need to, and complete that ordered pair for me. We got an answer? What'd you get?
61.
61, yeah. How'd you do it?
I did it 2 ways. Is I first used the table function in my calculator,
Oh, good.
replacing f of x with y.
Good.
And then the second way is replacing the x in 4x squared minus 3 with negative 4.
Good, good, good. So really all they're asking us to do here is we're inputting a 4, right? Negative 4. That's the x coordinate, so that becomes the input, right? So then we just want to figure out what is the output is going to be f of negative 4. Well, negative 4 squared is positive 16, times 4 is 64, minus 3 is 61. Good. And so, yeah, let me show you the table function. That's a good way to do it. Tables, especially when you're evaluating a function at many different places, the table function is pretty handy. So if we go into, we know how to do this with Desmos Scientific. We just define f of x and then plug in negative 4. If we're using Desmos graphing, we can use the table feature, and we could do something like this. F of x equals 4x squared minus 3. And it gives me a graph. I don't really care about the graph at this point. I'm just going to make a table, though. And in Desmos graphing, here's how you do it. It's really cool. You just go up to the little gear, and in that first row where I've defined the function, I can hit the table, create table button, and it creates a table. Now, I don't really like those values, but I can type in any value I want to. In fact, I'll just remove all the values except 1, and I can plug in any value I want. If I put negative 4 in there, it tells me the output's 61. So if I had to input a whole bunch of different values, the table would be a pretty convenient way to do it. Everybody see that? Okay. Here, I'll leave a picture for our notes there. Okay. And then what would I do here? I mean, just to kind of tell me what would my process be on number 11? Okay, good. I need to figure out what is the output number, Q of 4.5, right? Step 1, and then just subtract that from 7. So if I plug in 4.5 into Q, I get, when I do all the calculations, I end up getting positive 77.625. 7 minus that number is negative 70.625, and so that's my answer. Okay, give me thumbs on that. Everybody see that? Okay, so when I see that Q of 4.5, again, I'm just thinking That's an output number I have to calculate. Okay, what about number 14? What am I going to do there? Take a look at that one. Yeah, good luck. Take it to them. So we set 3x plus 19 equal to negative 62. Exactly. Now, do you see why we're not inputting? This is different than the last examples. We're not inputting negative 62 into the function. Negative 62 is the input or the output? It's the output, right? It's what f of x is equal to. So I'm setting the function equal to negative 62, and then the math gods, that's my way of asking the math gods what x is, and they tell me back through algebra, right? So we would just subtract 19, divide by 3, and I end up getting negative 27. Okay, there is a way to do this using a graphing utility also. In this case, it's not a big deal. That's pretty easy algebra, but this might be useful sometimes when the algebra is a little tougher. So what can we do here? Any suggestions?
Define the function.
Okay, define the function. So I'm going to do f of x equals 3x plus 19, and it gives me a graph of the function. Now, I can't just input negative 62. How am I going to find negative 62? And I'm going to use the graph of the function for this. It's a little trickier, isn't it? Because I'm trying to find where on that function the output, which is the y coordinate, is equal to negative 62. So one strategy might be to just drag a point along the function until the y coordinate is negative 62. Do you like that one? I don't. That's going to be kind of time consuming, and this thing takes little tiny steps when I drag it. It might even skip over negative 62. There's no guarantee it's even going to hit negative 62. So how could I make that a little better? I want to find the place on the red graph where the y coordinate is negative 62, because the x coordinate at that point is my answer, right? Everybody get that? These are all just, these ordered pairs are all just inputs and outputs, right? I want to find the input when the output is negative 62. We need a better strategy, though. Any ideas? Not so much, because with the table, I can only alter the inputs. I can't alter the outputs.
Well, yeah, because on my calculator it's different, actually. So.
Well, it shows both, but here's my point. Like, if I make a table out of this, I can't go over here and write, like, I can't write 20. I can't put anything in there, see?
And you just said 3x plus 19 equal to negative 62.
Okay, if I do that, equals negative 62, it gives me a weird kind of an answer. I mean, it does.
That's the point where I didn't.
Okay, it does. You're right. You're right. It won't do that on all types of graphing technology, though. You're really close. We want to make a graph, but instead of graphing the whole line, really, what's the y value we're focused on that we want to find? Negative 62. So how about if we just graph, what would the line y equals negative 62 look like? Y equals negative 62. It'd be a horizontal line where every y coordinate for every point on that line is negative 62, right? That might be useful. What if I graph y equals negative 62? Aha. Now I'm guaranteed that the point of intersection is going to have a y coordinate of negative 62, because every point on the blue line has that y coordinate. Everybody see that? So what's the answer? Negative 27, right? It's the x coordinate at that point of intersection. Everybody see that strategy? That's a pretty good little strategy, isn't it? Here, let's take a picture of that. So good, we're going to get a picture for our notes. Oops. do that? I'll put it up here, how about? It's going to be pretty small. Yikes, that's really small. I'll put it on the next page. There you go. Okay, what about an application like this one? So Owen paid a landscaping company $108 for an initial lawn treatment and then $74 per month thereafter. So if we let T be the number of months that he's had this contract, does everybody see that the function P of T equals 108 plus 74T represents the amount of money he will have paid after T months? Give me thumbs on that. Does that make sense? Right, because 108 is the starting value or the initial value, right? The fixed cost, whatever you want to call it, and 74 is the rate, the monthly rate. So what does P of 24 represent? I want to know, what does P of 24 represent? I don't really care what the what it is equal to. What is it again?
The amount of money he paid after 24 months.
You guys agree with that? Yeah. Doesn't that make sense? We're inputting a value of T that's equal to 24, so we're inputting 24 months and it's outputting the cost after 24 months. Okay? Good. Question B. How long has Owen been receiving lawn service if he has paid a total of $29.94 to date? How would I find out?
Do the graphing thing shows us.
Okay, yeah, so what would I be plugging 21 or 29.94 in for? For T? P of T, right? That's a value of P of T, isn't it? That's an output value. Okay? So we could do the same trick. We could do our graphing trick with this. We're just going to change our function here to, I'm going to call it P of T, I guess. P of T. And now it's giving me an exclamation point. What's wrong with that function right now? Yeah, I need to use T's. If my input is a T, I need to use T's in the rule or the formula part, right? 108 plus 74T. Okay, there's my graph. And what Y value am I plugging in? Yeah, 29.94. And then I would just have to go find that intersection. There it is. Okay, does anybody see a danger here of just clicking on a point? Like, is that the answer? Mm-mm. What is that? How come that point was there? Yeah, that's the y-intercept, right? Desmos doesn't know which point you're looking for. It just gives you options for all the interesting points. So what I should probably do here is zoom in a little bit so I make sure I get the right point. I want that point, not that one, right? I want the point of intersection, so I'm going to choose that one. So what's the answer? How long has he been receiving lawn service then? 39 months. Yeah. Okay, so give me thumbs. Does that all make sense? Okay. We're getting there. Okay, what in the world? 16. What's that mean? What's f of x, everybody? Okay, but what is the function f of x equal to? F of x equals negative 4x plus 9. That's telling us, that's giving us a roadmap, right, for finding outputs based on inputs. It tells us how are we treating the inputs. We're multiplying by negative 4 and we're adding 9. What's f of 2? Or what's f of 27? I don't want a number, but what would I do? Negative 4 times 27 plus 9. What's f of pi? Negative 4 times pi plus 9. What's f of a?
4 times a plus.
Yeah, what's f of dog? Negative 4 times dog plus 9, right? It's just a pattern we follow. So what is f of the quantity c plus 2?
Negative 4 plus times c plus.
There you go. Negative 4 times the quantity c plus 2 plus 9. Which we can simplify. Right? I could distribute the negative 4 and collect like terms, no big deal. 19, same thing. If g of x is x squared minus 5, g of the quantity a minus 3 is just the quantity a minus 3 squared minus 5. And then we could just FOIL out a minus 3 squared, collect like terms, and get an answer. Okay? Okay, how about this one? This is kind of a weird one. This is an important function, though. It's a function we use. This shows up in computer science quite a bit. It shows up, like we see this in calculus. Let's look at part A. What's f of 9, if I plug that in? What's the absolute value of 9? So what's the output? 1. Okay. What is f of negative 9? Well, yeah, how'd you get it? Negative 9 over absolute value of negative 9, right? What's the absolute value of negative 9? There you go. Okay. Now, tricky one. So follow the same rules, right? I'm just going to get r squared divided by the absolute value of r squared. What's that? Remember, I can't just do simplify stuff that includes absolute values. I've got to find a way to get rid of the absolute value bars before I can proceed with this. What's 3 squared? 3 squared, 9, right? What's negative 3 squared?
9.
Positive 9.
27.
3 squared? Negative 3 squared is what? 9. What's negative 2 squared? What's 2 squared? Okay. What's the answer? It's going to be 1. How come? Yeah, what can you tell me? What is the value if I plug any real number in other than 0? Because I can't plug 0 in. That'd give me 0 on the bottom, which can't do, right? If I plug in any non-zero real number into r squared, what can you tell me about the output of r squared? It's always positive, right? If I square a negative or I square a positive, I always get a positive outcome, right? So the absolute value of r squared is guaranteed to just be r squared, right? Because r squared is already positive. Everybody see that? Okay. So it's 1. Could I do the same thing for r cubed? Like if I tried f of r cubed, I'd get r cubed over the absolute value of r cubed. Is r cubed guaranteed to be positive? No, it could be negative or positive, so we don't know what the outcome of this one would be. We don't know of whether it's going to be positive 1 or negative 1. Could be either one, right? So we couldn't really go any further with that one. Okay, last one. I'll turn you loose. This doesn't look very mathematical, but we can think of it in a mathematical way. The coffee shop menu consists of items and their prices. So part A, is price a function of the item? So if I'm talking about price being a function of the item, in part A, what are we considering to be the input and what are we considering to be the output? Yeah, right? If we talk about f of x, x is the input and then the function is the output, right? So if we're talking about f of item, function of item, the item must be the input. Okay? So part A, input equals item, output equals price, right? So if we're using that kind of a relation, where input is the item and output is the price, give me thumbs up or down. Is that relation a function? What do you think? I'm seeing lots of tentative thumbs up. You're right, it is. Right? Because it passes the function test. Each input, meaning each item, only has one output, one price. If I buy a jelly donut, there's only one price that I'm paying, which is $1.99. Everybody see that? So yes. What about if we flip it around? Is the item a function of the price? So if we're inputting price and the item is the output, is this a function? No. How come? Kimura, what's the problem? Yeah, right. If I input 199, there are two possible outputs, so it fails the function test, right? So the answer would be no. Okay, give me thumbs. Does that make sense? All right, I'm going to let you work. If there were no chocolate donut, then it would be fine. Yeah.